Math 3, Unit 11, Section 4. One thing I want to remind you guys of is Desmos.com, which is a pretty amazing calculator, online graphing calculator, and a great way for you to like double check that you have the right information. You're not going to be able to use a calculator on the test when we take this test, so you're going to need to understand how to do all this without using Desmos.com, but I like using that as a check to see if I actually graphed it right. Okay, so before we start with graphing a log function, I want to talk about when we graphed exponential functions. Okay, so we did this earlier on in the year. And I'm just going to say, let's say my equation is y equals 2 to the x power. So if I were to make a chart for this, and that is pretty much how we graphed this originally, we plugged in values for x. Okay? So whatever's in the exponent is normally the values you want to choose to plug in. And so if I plug in 0 here, what is 2 to the 0 power? 1. If I plug in 1, 2 to the first is 2. If I plug in 3, I get 8. Now, if I plug in negative numbers like -1, what happens? You get 1/2. You get a fraction. Good. And so if I plugged in -2, I would end up getting what? Not -1/4, just 1/4, because the negative exponent makes it the fraction. Okay, so in terms of graphing it, so we have 0 up 1, there's a point. At 1, it's up 2, and there's a point, and 3, we're just going to say 8's like up there. Okay, and then we go to our negative numbers, and we just get closer and closer to that x-axis. If you have a phone now, please put it away. Will it ever touch the x-axis? Is there any way of me ever getting a value of 0 for y? No. We're only going to get fractions, like smaller and smaller fractions. And so we talked about how that ends up making like an asymptote here, where it's like getting really, really close to the x-axis, but it'll never actually touch it. Okay? Are we all okay with this? So we're going to see how this graph is going to compare to our log functions. So we have some values here for x that they've given us here originally. And so if I were to plug 1 in here for x, I would have log base 2 of 1. And so that is saying 2 to what power will give me 1? 0 is correct. Okay, and remember, you can always think of this as well as like 2 to the x power equals 1. You could change it to exponential form if you want to, but for the values that we're choosing here, I think you guys can figure them out in your head. So when I plug in 2 here, log base 2 of 2, because we're plugging into this equation up here, 2 to what power will give me the answer of 2? 1. Are we okay? Yes? All right. So then we have log base 2 of 4. 2 to what power will give me 4? 2. Good. Log base 2 of 8. So here, 2 to what power will give me the answer of 8? 3. Log base 2 of 1/2. -1 is correct, right? If you want to look at this in exponential form, that would be 2 to the x equals 1/2. And so in order to make those, put that up here a little more, in order to get those at the same level, we'd have to bring it up and get a -1 exponent. So that means that on log base 2 of 1/4, 2 to what power will give me 1/4? -2. Good. And then log base 2 of 1/8 will be what? -3. Are we okay with that? Do we have, no? Yeah? Okay. So let's go ahead and plot these points on this graph. Is that okay? Do we have a question? All right. So our x value is 1, our y value is 0. So we go right 1, up 0, make a point. Why did I do that? Right 1, up 0, make a point. Okay. This should not have been there. All right. Then we're going to go 2, up 1. 4 up 2, 8 is up 3, so 8's over here. And then we have our 1/2 went down -1, our 1/4 went down -2, 1/8 went down -3. And do you think, is there ever a value where I could get a 0 for the x? Is 2 to some power ever going to give me the answer of 0? No. And so it's similar, again, to our exponential function in that it has an asymptote here where the graph will never cross. So in each of our graphs, they want us to give some information. And looking at what we have here, what is our x-intercept? What is it? There is an x-intercept, right? This is our x-axis and our y-axis. So what is our x-intercept? 1, 0. Okay, so we'd write that as an ordered pair, 1, 0. Is there a y-intercept? No, the line will never cross the y-axis, so we're just going to put none. What does our domain mean? What do you guys remember? Good, your x-axis going left to right. So what value do we start getting on the x-axis? It's basically just past 0, right? And so what do we do in order to write that? That's where we use, remember, the parenthesis and 0. So it means that it gets really close to 0, but it doesn't actually touch 0. If it touched 0, we would use a bracket, okay? And then it's going to go all the way to what? Infinity. Very good. And say that one more time. Oh, you can. So 1/8 is at -3. I put it just right down there. Oh, we could put in more values, right? I could put in 1/27. I could put in more values. We just stopped here. Does that make sense? But it goes on forever. It's going to get closer and closer to the x-axis. So basically, wherever your asymptote is, that's where your graph is getting closest to, wherever that asymptote is. In this case, it's at 0. Okay? No, and so that's why you use a parenthesis, because it's not actually going to touch 0, but it's going to get as close to 0 as it possibly can. Okay? Now for the range is your y, and so that's going from your smallest value up to your highest value. And so it's going in both directions with arrows, which means it's going to be what? -infinity to positive infinity. Where is my vertical asymptote? And it's an equation. Close. So when you have lines going up and down like this, it's going through the value of x, because it actually equals every y value, but it only equals one x value, right? And so it's x equals 0 is my vertical asymptote. On my exponential functions like this one had an asymptote at y equals 0. Okay, so that's y equals 0. This one right here is x equals 0. My point that it intersected that x-axis was at 1, 0. Okay, do we want to ask any questions right now about this graph or the information we have there? Okay, let's try another one and see what happens. Okay, so on example 2, what happens when we have a value like this at the end of an equation? What happens? Very good. It translates, right? And so because it's not in parentheses or anything, we know that that's telling us it's going to be translating up and down with the y-axis. So specifically, this is going to translate how? Now, if we go back to thinking about exponential functions, any exponential function, like if I took 2 to the 0 power, I get what value? 1. If I take 3 to the 0 power, I get 1. If I take 10 to the 0 power, I get 1. So guess what? All log equations, before they're translated, they all have the point what? 1, 0. So remember how we've been graphing this year, and I personally think the easiest thing to do is at 1, 0, we mark that with an X, and then we translate from there. Also, all of them are going to have this vertical asymptote at x equals 0. But if we translate our graph at all going right and left, we have to also move the asymptote right and left that many spots. Now, in this case, we're translating down. So is my asymptote going to change at all? No. And so I'm going to go ahead and draw my asymptote here. And again, that is at x equals 0. And then this point is going to translate down to. We're going to make that point. Okay. All log functions, pre-translation, like their parent graphs, are all going to look like this. They're all going to get really close to the x-axis and then go out and continue going up. So we could just draw this here, but we want to be more accurate in seeing like what our x-intercept is and our y-intercept. Is there going to be a y-intercept? No, we already know that, so I'm going to put none here. For the x-intercept, I'm going to show you how to find the answer mathematically. Okay, so when you're finding the x-intercept, what equals 0? When you want to find the x-intercept, you're plugging in 0 for y and you're solving for x. So in this case, I'm going to go over here and I'm going to plug in 0 for y. Are we okay with that? All right. So my equation is going to be 0 equals log base 3 of x minus 2. What would I do to solve this equation? You'd start by adding 2 to both sides. Good. Okay, I'm going to rewrite this because I always like seeing the log on the left side. So once I add the 2 over, I'm going to rewrite this as log base 3 of x equals 2. Could you guys rewrite this in exponential form? How would I rewrite it? 3 to the second power equals x. So what does x equal? 3 to the second power is 9. 9 equals x. So therefore, my x-intercept is what ordered pair? 9, 0. We plugged in 0 for y and solved for x. 9, 0. That goes a little bit off the graph. 9, 0 right here. And so now that we have that point, we can draw the function. And I didn't draw it great. It should be going through that point. Sorry. Okay. All right. What is my domain? What is the smallest x value? 0. Okay, it's getting close to 0. Okay, and then it's going all the way to infinity. My range is going to be what? Negative infinity to positive infinity. And my vertical asymptote is at x equals 0. Okay, do we have any questions? We didn't have to move the asymptote because we're going up and down, and so it's still saying at x equals 0. Okay? It's only if we're moving the x value. Was there another question? No? We're good? Okay. What's going to happen on example 3? Okay, so it's going to translate, right? Which way is this going to translate? Right to, very good. So remember that when it's in parentheses, it's going right and left, and it's always the opposite because we'd set x minus 2 equals to 0, and we know that it ends up translating right too. So if we go here to the point that is originally on all the functions, which is at 1, 0, we are now going to go right how many? 2, right 2. 1, 2. So this is actually where I'm at. My asymptote is always at x equals 0, but then because I'm moving right 2, I have to move the asymptote also right 2. So here is now my asymptote. And that's at x equals 2. What is my x-intercept? What is this order pair right here? This is 3, 0. Will I have a y-intercept? No. And because I have, once you have your x-intercept and your y-intercept, you can go ahead and draw your graph. You don't have to do any extra points, okay? What is my domain going to be this time? Very good. Parentheses 2 to infinity. Because this time we're starting at 2. It's not at 0. And then the range is still going to be what? Very good. And my vertical asymptote is at x equals 2. Very good. Any questions there? Okay, example 4. We know natural logs, again, they're the same as logs. It's just specifically basey, okay? But like we've talked about, it doesn't really matter what the base is. We're always going to end up getting that 0, 1 point, right? Or sorry, 1, 0 point. So I'm just going to put that x there. Now, what does it mean when you have the negative in front there? It reflects, very good, and specifically, it reflects which way? Very good, reflects over the x-axis. So we have a reflection over the x-axis, okay? And to think about this, if you're reflecting over the x-axis, this point isn't changing, right? Because it's on the x-axis, but what's going to change with the curves? So yeah, this one, it's going to end up flipping and it's going to be going up, and then this one is going, so it's going to get closer on the top part here, and then it'll curve that way. Does that kind of make sense? All right, so this is reflecting over the x-axis, and then it's also going to do what? Very good. This is going to go left 1. Will my asymptote translate this time? Yeah, so whenever we're translating left and right, that asymptote will move with it, okay? So where is my point going to be? When I go left 1, we're going to be at what? 0, 0. Okay? My asymptote, when I go left 1, is going to be where? So that's at x equals negative 1. So right now, if I go over here, what's my x-intercept? 0, 0. What's my y-intercept? It's also 0, 0, right? They're both there at that point, so it's crossing the x and the y on this one. And so let's go ahead. So when we're graphing this one, again, normally it gets close here to the asymptote going down, but when we do the reflection, it's going to go close going up. And then we're just going to draw it like this. What will be my domain on this one? Not 0. It's starting at, very good, negative 1 to positive infinity. What's my range? Negative infinity to positive infinity. And then my vertical asymptote is at x equals negative 1. Okay, last one. This one kind of has a few things going on. The first thing I would do is rewrite this one because it has the 3 here in front, and I would put the 3 in the back. And so I would rewrite this as y equals negative log base 2 of x plus 2 in parentheses, and then there's a plus 3 at the end. There's the few things that are happening here is, first of all, what does that mean when we have the negative in front? Okay. Reflect over the x-axis. And there didn't happen to be any reflections over the y-axis. But if you had a negative in here with the x, that's when we'd reflect over the y-axis. Okay? And then what other ways is this going to translate? Left 2, up 3. Okay. So our original point is always at 1, 0. And then reflecting over the x-axis, this point would stay there. Okay? If it had been reflecting over the y-axis, it would have been since it's 1 away from the y, we'd go 1 away over here, right? Does that make sense? But you do your reflection first. So the reflection stays the same. And then from there, I'm going to go left 2 and then up 3. So there's my point. Where will my vertical asymptote be at? Very good. So normally it's at 0, and it's only left 2. And so we have our new asymptote, and that's going to be at x equals negative 2. Now, am I going to have an x and a y-intercept on this one? Yes, because this one, because of reflection, it's going to be starting up, right? And then go down. And so it's going to cross the x and the y-axis. So we need to go ahead and find those points. Okay, so let's start with our x-intercept. For our x-intercept, we plug in 0 for y. Good. When I write this out, I get 0 equals negative log base 2 of x plus 2 plus 3. What will I do first? Subtract 3. So I have negative 3 equals negative log base 2 of x plus 2. Since it's negative on both sides, negative divided by negative ends up making a positive. So I'm just going to change these to positives. Instead of going through the whole process, like if you have negative 1 equals, let's just say negative 1x, we go divide by negative 1 to both sides, and those both end up becoming positives. Okay? All right, so now what will I do to change this? With the 3 being on this side, sometimes it's confusing. If you want to rewrite this as log base 2 of x plus 2 equals 3, you could rewrite it that way. When you see it that way, do you know how to rewrite this in order to find out what x is? How would I write it? Yep, 2 to the third equals x plus 2. What is 2 to the third power? 8. 8 equals x plus 2, and then you would subtract 2, which would give us x equal to what? 6. So my x-intercept is at 6, 0. So I'm going to write that over here. X-intercept, 6, 0. On the graph here, we're going to go right 1, 2, 3, 4, 5, 6, 0. There's my x-intercept. Okay, y-intercept. How do I find my y-intercept? Plug in 0 for x. Okay, so going back, I'm going to plug it in this way. Y equals negative log base 2 of 0 plus 2 plus 3. What is 0 plus 2? 2. So I have negative log base 2 of 2 plus 3. 2 to what power gives me 2? 1. So that means we have a negative 1 plus 3, which equals 2. So the y-intercept is at 0, 2. And then we can, because of the reflection, and plus we found all those points, we know that the graph curves like that. What's my domain? Very good, -2 to positive infinity. What's my range? -infinity to positive infinity. And my vertical asymptote is at? Any questions?